بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Okay, so let's continue. Today we're going to have a practical lecture about Python. I'm going to do some coding to explore some of the capabilities of the Python syntax. And I would like to remind that I provided you two notebooks that contains a comprehensive coverage of the basic syntax of Python and also the built-in data structures. Today I'm going to use these different concepts to build a simple application for weather analytics, where we are going to process temperature information and perform some kind of operations and manipulation of the data, just to show you, introduce some of the basic concepts of Python, and also get started with data analytics, things that we are going to explore in more details in the next lectures with NumPy arrays and Panda frames, Matplotlib and Seaborn. But today we're going just to use the elementary basic syntax of Python to introduce this one. So I'm using VS Code. In some other examples, I will be using Colab, just because maybe most of you are still beginner with Python and Visual Studio Code. So I'm going to use it in this first lecture of hands-on activities to introduce the also VS Code and Python scripting language. So in today's lecture, we're going to suppose that we have a data set containing daily maximum temperature, and we want to calculate the average temperature and also do some other operations like filtering the temperature, the hot days greater than 30, and exploring the different operations and the basic syntax of Python. So first of all, I'm going to work on the package that I have created, and I will add a new file using this button called weather.py. And here I'm going to write my code. So first of all, I'm going to define a list of temperature. Is it clear? Okay, list of temperature. And of course I have Copilot, so Copilot is going to propose the code for myself. Okay, so this is a list of temperature. We define a variable, equal, and some kind of temperature. I'm going to change them to look more like a regular temperature, for example, 25, 31, 35. Let's change them. 40, 39, 41. Okay, 32. Let's say 25 and 28. So this represents a list. Okay, we can print these temperatures. Okay, so let me just write the code. So printing the temperature is going to show the whole list. And by the way, when you want to execute the code, so you have to differentiate between the workspace and the package. Okay, so now I'm in the workspace. So if I check, I'm not inside the package, and I created the Python script inside the package. So I need to go inside the CS316 package that we have created, and we will observe that inside we have the weather.py, which we are going to execute. And now I'm working into the virtual environment that we have created yesterday. Okay, and now I would like to execute this code, Python weather.py. And it is executing. Now it is showing the temperature, but now I don't know, okay, if you have many lists, you don't know which one to print, so we can add some text here, okay? And we can do temperatures. And then this is one of the ways on how we can use print. Okay, we use the comma in order to separate between the text string. So now it's going to print it in this way. So let's see that. Now let's calculate the statistics using the built-in functions in Python. So how to calculate the average temperature here? Okay, we want to calculate the average temperature. Okay, so the first thing I need to calculate the total days. I will do it into steps. Total number of days. How do we get the total number of days? Yeah, so we're going to take the length of the temperature list. And what we need to calculate also, the total temperature, the sum, and then we will divide. Okay, so the average temperature will be equal total divided by the total number of days. Okay, of course, there are several operations in Python, same as in any programming language. Okay, this is how we do exponentiation. This is how we do equality, non-equality, greater, less than, or greater or equal, less than or equal to. Yes. So I'm inside the package, inside the 316 CS316 package. I made this file weather.py, and then I'm writing a script inside. Yeah, by default. Okay. There will be other similar functions with pandas, for example, and NumPy arrays. But these are the built-in. I'm going only to use the built-in function of Python. I didn't import any library here. Okay. We can also do this in line. Okay. Another way to calculate the average temperature will be equal. We can do sum of temperature divided by the length of the temperature. So it's possible to define variables or to just then do inline. So displaying now, display the average temperature. Okay, one of the ways is like we did above. Average temperature is like this, or we can do formatted printing. Okay, so I can do F, double quote, and then average temperature. So this is a formatted visual printing or display. You can specify how many floating points if it is displayed here, and with executing. So you can see this is without making formatting. It only showed 31.9 and here 0.19. So it's our 2-digit on floating point. And look at the difference. So here we have separated the print with a comma, and here we put everything inside the string, and the variables will be between curly brackets or curly braces when you have formatted output. Okay.
What's the escape factor if we want to use the curly brackets in the string?
Sorry?
If we want to use include the curly brackets in the string.
Here inside?
Yes.
Yeah, you can. Let me check. I think we should make a slash, if I'm not wrong. No. Yeah, the way to do it, I'm not sure whether this is possible. Yeah, in the formatted string, I'm not sure whether this is allowed. I didn't explore this before, yeah. Yeah. Okay. So, like in every programming language, we can also do for loops or loops and conditions. Okay, loops and conditions. So imagine that we want to filter out all the temperature greater than 30, and we can do that. So we have to go through whole list, and then we can use an if statement to only keep the temperatures. Okay, so filtering temperatures above 30. Okay, so how can we do this? Okay, let's think about an algorithm, and then we implement it. We want to capture the hot days. Yes?
Use a for loop, then I use an if statement inside the for loop.
Yes, but we need to contain first another list where to keep the hot elements. Yes, so I can create hot days like this, and then we can use a for loop for temperature in temperatures. So this is how we do it. Okay. Yeah, I try to increase, but the problem, I'm not going to have enough space. It's not clear? Which tab?
That's for
On the left.
This one?
Yeah.
You can click on top.
But still, the problem is the vertical view. Anyway, it's clearer now?
Yes.
Okay. So this is how we do it for every temperature in the list. Okay, we can just filter the temperature that we don't want, and then we can add using append. Okay, the list of temperatures. There are other ways also on how we can do them. So Python is very flexible and dynamic language. I'm going to show you some other alternatives on how you can do filtering by building a filtered list instead. So you can see now we keep only the days that are greater than the conditions. So another way to do it, okay, hot days is to create a list and put the for statement inside the list. So we don't need to create an empty list in the beginning. So this list will be all temperatures. So it will be temperatures for temp in temperatures and greater than certain condition. This is a way on how we can build. Okay, this is what we call list comprehension.
نقدر نحطها في البرنت على طول بدون ما نسوي ليست.
Mhm.
نقدر نحطها جوا البرنت على طول بدون ما نسوي ليست.
Yes, it's possible. It's possible to do that, but usually we put it into a variable and then you can manipulate this variable. Okay. So if you want also to calculate the average of hot days, you can do the same. The average of hot days. So basically similar to what we did before. Okay. If I want to make it formatted, we can use the following instruction. And now executing this one. Okay, so you can see the difference between formatted and non-formatted. Okay. Of course, you can make else if you have another condition. And if you want to make something general, you can use else. Okay? So we have if and else. Okay, if you want to go through other conditions. Okay. So now let's talk about built-in data structures. And you can start with dictionary. So a dictionary is a collection of key value pairs. And the key is unique, and then we can assign a value. This is similar to map in Java, some of the ways. Okay? And it has like string JSON structure. We call it a dictionary. Okay, the key is unique, and the value can be of any data type. It is mutable. You can change it. Okay, and it's completely unordered. Now, let's try to create daily temperature. And I'm going to put some values inside this dictionary. Okay, so this is a key, and the key is unique because here we're going to have like an ordered list based on the date. Okay?
Can I ask a question?
Yes.
كيف تقدر تكتب التمبريتشر من الليست اللي فوق؟ كده بسرعة.
This is it's used AI. It's called Copilot on VS Code. Okay.
تكتبها بنفس ترتيب الليست صح؟
Yeah, Copilot is going to, this is what we call code recommendation. It recommends you some code. If it is correct, I can press. If it is not correct, but I don't recommend to use any kind of AI tool at this time. You need to write the code yourself, because in the exam you won't have access to any of these tools. So just practice Python as much as possible, and then when you become expert, you can have the luxury to use this AI tool to facilitate the development and speed up the productivity. Yes.
So the key is always the first entry.
Yes, the key always in the first, and then we provide the value. So the value can be the same. I can have a temperature, but the keys must be unique. Yes. Yeah.
يعني احنا مثلا تكتب ان اول شيء الديت بعدين
Yeah, this is the date. It's unique. احنا قلنا الآن the key is unique.
احنا عندنا تو فاليو في الليست.
Yes, key and value. This is the key and the value.
مو لازم تكتب الاثنين.
Yes, مثلا لو نحب نعمل مثلا student dictionary. Okay, I can use, for example, name is the key and John is a value. So many people can be called the same name. But the name here, okay, I cannot make another field that is called name. Okay, sorry?
students وين declare this temperature.
What do you mean? It's the same thing.
عرفنا انها name
How عرفناه? Yeah, daily temperature, it's a dictionary. It's this dictionary. Yeah, this is how it's defined. Okay, student, it's this dictionary. This is how it is defined. Yes.
دكتور
dictionary with this braces, it's different than the normal bracket.
Yeah, it's with these curly brackets.
The normal
Yeah,
bracket
the
is-
normal bracket, this is a list.
Okay.
Okay, if you want to define a tuple, look, tuple, and for example, if I create unique temperatures, so if I make a tuple like this, it has temperatures that are duplicate. For example, I will use 23 two times, okay, 25 two times, and so on. If I make print unique temperatures, sorry, yeah, this is tuple, not set. You can define also set. So this the tuple, the difference between the tuple and the list is that the tuple is immutable. You cannot add elements, you cannot remove elements, but it can contain duplicate. Okay, so the set is actually unique, set of unique temperatures, and it's defined between curly brackets like a dictionary, and in this case, yes. So this is not called this is tuple. Okay, tuple temperature, and this is, I'm going to call it a set temperature. Yeah. Just a moment. Let me finish first, and then you can ask. Okay, now, if I print unique temperature, or sorry, I'm going to call it tuple, and this one I'm going to call it set of temperatures. Now, after the execution, look at the set, doesn't contain any duplicate. I explained this with all details and all the possible operations in the notebooks that I provided to you, okay? Yes?
What's the difference in the syntax between them?
The difference?
It's how to make a tuple and how to make a set.
It's the type of the brackets that you do. These are parentheses, okay? And these are brackets, and these are curly brackets. This is the difference. I will give you the code and you will have the video, so you can review this at your pace. Okay. So what we can do with the dictionary, we can do several operations. For example, access a certain element, value in the key. So how can we do that? So we can do the following: the temperature on the first date. So we can filter the dictionary by the key. So this is going to return the value that corresponds to the key. And since the key is unique, so we're going to have only one answer. This is why the key has to be unique in dictionaries. We can add a new element. Okay, so you need to just define the value for a particular new type of key. So for example, I want to add a new record on 7th of January 2023. So this is possible in this way. You can also delete or update a value. Of course, you need to make an assignment to an existing value, for example, changing its value. Or you can also delete the key value pair like this. Okay, using del. And del basically, it deletes any kind of variable. If you take any variable, use del, is going to delete it from the memory. It means remove all the variable from the memory. So there is no memory allocation. Yes?
For this example, can you print the dates which have this value? So doing the opposite, which is finding the key from the value.
I couldn't get your question.
So can we find the value, sorry, the key from the value? The opposite.
No, because the value is not unique.
So let's say that we have
You can only use the key to find values, but not the opposite. Yes, it's only way around. So we can also do filtering like we did with the list. We can do that with the dictionary. We create a dictionary of date and temp. So date is what? Is the key, and the temp is the value. And then the for loop is going to take, okay, these two, the key and the value, and we will use daily dot temperature items. Okay, so let's do this example, even using a for loop. Go over the elements using a for loop. Okay, so this is the basic instruction, for loop over a dictionary. Okay, so you can do a for loop for the key and the value using daily temperature dot item. Okay, and also we can do a for loop going through only the keys. Through the keys. And this is the syntax. Okay, so both are possible. Now, if you have date and temp, whatever, for example, you make temperature on date is equal to the temp, because here is going to do the mapping between the key and its corresponding value. Now, if you go over only the keys, in this case, in order to access the value, you need to make between the brackets. Okay, call it with the key between the brackets to get the corresponding value to that key. These are the two different options. And likewise, we can do the filtering by creating a list, a dictionary based on the filtered values. And let's try to execute the code. Okay, so you can see now it's printing the cold days that we've done before and calculating the average. These are the different temperatures that we've displayed. Okay. Now, if we want to do the average of filtered temperature of the hot days, average temperature of the hot days, how can we do it? Yeah. So we have also some additional functions that we can apply on dictionary. We have dot values, and we have also the dot keys. You can use dot keys to get all the keys as a list, okay, and dot values to get all the values as a list. So it's going to make the sum of this list. So let's print this one, list of all temperatures. Okay, so we can define a list that will take all the different values and print them. So executing the code, this is the extracted list from the values. And of course here we need to do typecasting, because dot values is not of type list natively, so we do typecasting in order to convert it to a list, and then it will be used like a normal list that we have created in the beginning. Okay. So as already mentioned, if you want to get the keys and the values alone, so okay, get the keys and the values of a dictionary. So this is how we get the keys. Now you can get it like this, and let's print the type. Look, type of date, which is the type of that extracted list. Look, it's a dictionary of keys. This is the type. So if I want to convert it to a list, okay, dates list equal list of dates, and now I can print the type of date list, so the type will be different. Okay, now we have a type list, and this is dates. Look, it's a dictionary key, okay, that will contain also a list. So it's an object that contains a list. And now if I want to convert it to only a list, in this case, I need to make type casting. Of course, the casting must be compatible. In this case, it's possible. Okay. And you know, all along the code, you can observe that the code is pretty much indented. Now, if, for example, this indentation is not correct, so it will make a syntax error. You cannot write the code in a messy way. So the block is defined through the indentation. Okay, let's go over. We can also get the values. We already made the values. Now, if I want to get the unique values of the temperature, how can I do it? Okay, get the unique temperature values. I want just to see what are the unique temperature values. We can typecast into set, yes. Apply it to what? To temperatures dot value. So you can cast it to list,
Yes.
you can cast it to set, you can cast it also to tuple, depending on what you want to achieve. Check if a key exists into a dictionary. That's also possible before trying to access a key, because if you access a key that doesn't exist, this can result to an error. Okay, so this is like using instance of in polymorphism to check whether the type is of the same instance. Now, yeah, print if in daily temperature. So did it print it or not? Because
Instead of checking if the key 2023 is
yes, print the key exists, but it's not showing. So do we have this value? I think so.
I think you deleted it.
Maybe, yeah, it was deleted. That's a good point. So now let me remove delete, or we can check another value. So this value doesn't exist. So I'm going to use this value. And this is important because look, if you try to access a value that doesn't exist or a key that doesn't exist, so in this case, it will result into an exception. Okay? We can also do try catch if I don't want my program to crash like this. So this is an exception saying that the key error doesn't exist. So in this case, if you want to surround with a try catch exception, or we call it try except, so we can do try, this one, just a moment. Okay, this is the indentation, and I need to do except key error. So there are different type of exception. We can make a general exception like this. We can do exception as E, and then printing the text of the exception. That's also possible. Okay, let me make it formatted printed. Okay, and here error E. Okay, so in this case, of course, I'm going to try to access something that doesn't exist. So the key doesn't exist, error. The exception is general, but if you want to, if you have different type, you want to differentiate between what exception occurs, you can do except several times. Except key error, the key that, okay, here is going to be general exception occurred, and this one will be a specific exception for a specific error whenever it happens. Okay, so look now, if I do that, the key doesn't exist, so it went to the key error exception. And usually, you know, exception, probably this is the topic that is least taught at universities. But this is the topic that is most important in industry. Because you have to make sure that your program doesn't crash at all. Okay? So one of the things that are really important when you work on real life project is the try catch exception handling. This is really important. At least you need to handle general exceptions, so you make sure that you recover from the error and you have a backup plan to execute. Otherwise, if the system crash, the users are not will not be able to access your services. Okay. And now if there is any other error, for example, I'm not going to do that, and I don't know, for example, I don't define a variable here, so it's another exception. I'm not executing. It's not a key error now. Okay, this is 3. Still making a key error. I want to do something like another type of an exception, 2 divided by 0. Yeah. It's not going to, okay, anyway. But if I don't have this one, do I have still the exception? That's weird.
Was it because you printed the...
This one, look, print daily. Okay, this is 3. Let me make these 2. So all is correct right now, and then I will make x equal 2 divided by 0. So in principle now, I should have the general exception. Okay, that is what I expected. Voila. Okay. So what other concepts? Yeah, I will, just a moment. No, I don't need this one. So now I'm going to introduce a very important topic in modern programming, which is called lambda expressions. Have you heard about lambda expression? It basically exists in all programming languages or most of the programming languages, and it's kind of making a shortcut. A shortcut. It's pretty much useful, especially for some operations. It's not function. Okay, let me introduce functions first. You can define a function, for example, calculate the average of temperatures. And this function will take, for example, a temperature list, and then will return the average temperature. Now I can apply this one, so another one to filter the hot days. So we will encapsulate them into a function, and the function is defined by a def, and then the name of the function, and then the list of parameters. This is what we call the function signature, or the method signature, like in Java, but this is the way on how we define it. And then you need to do indentation in order to define the block inside, or the scope inside the function. Okay, so let's apply this function. Apply the functions. This is the average temperature. Okay, we just call the function and we put the list of parameters. And you can see, because Python by default is a non-typed language. So basically, you must know in advance what you should put over here. For example, if I put just the value, or let me define x equal to 30, and I put here x. So you won't find there is no any error, because it can expect any type. Okay, so in this case, if I do that, I will have the error during the execution, because this is scripting language. And to avoid this, in modern Python, it's possible to specify what's the type. It's optional. So in this case, okay, in this case, in principle, it should here determine that there is something wrong. So int has no length. So we can specify the type here and make sure that the type is respected. If I make int, I'm not sure, yeah. Still, it's a scripting language, so it's only during the execution. But now, when you put the type, at least you provide a clear specification, and even you can specify the return type. This is how we specify the return type. It's optional, but it's recommended. At least when you share your code with others, they know what they expect to have as an input type and as an output type. Yes?
When I specify the return type, would it give me an error if the return type is different than this one?
Yeah, this is an interpreted language. It will not give an error. It's only during the execution. If it is a compiled language, like Java or C, it will detect during even syntax error. Okay. Okay, so now, if we make it right, we'll get it right. Yes?
We specify that the return value is a float, but the return wasn't a float, and we run the program, then we get error.
No. This specification is just to illustrate it explicitly that this is the expected type. But it's not going to check syntax error when you write the code, at the time of writing the code. Okay? But when you share the code, now, for example, if you share these functions, from here it's clear, but from here you need to identify, probably, okay, it's more difficult to identify what are the type that you need. Because initially Python doesn't support any typing. It has dynamic typing. This is like the nature of Python. And this applies to all the variables, by the way. You can specify their type. Yes?
General question, you mentioned that Python is a scripting language. What's the difference between scripting language and
Compiled language.
Yeah.
Okay. Lambda functions. So when you work with Java, usually Java code or C code, you need first of all to create a binary code and then execute it. So you compile and then you run. Even if you click run, it's going first to compile. What does it mean compile? It's going to translate this English-like code into a binary code that the computer will understand. And then this compiled code will be executed later on. And this is why during compilation you will detect whether there is any syntax error before starting. So at least from syntax perspective, you will make sure that there are no errors. Typing-wise also. There are several rules that will be checked during the compilation. A scripting language, it will be executed line by line. So whenever, for example, if you make a mistake here, look now, I will make a mistake here. And now it's detected, okay? But still I can execute the code. Terminal, okay. Let me execute the code. The code is going to execute until it reaches, okay, this certain the line, and in this case, it will crash. So it is still able to execute all the line of codes that are correct, and it will crash at some point in time. This is how scripting language occur.
The executed part will be saved in the memory.
Yeah, this is what we call it the interpreted languages, compiled languages and interpreted languages. Python is an interpreted language. JavaScript is an interpreted language. Okay, so there are several languages. Like scripting languages are generally interpreted languages, not compiled languages. Clear? Okay. So lambda expression is also very powerful tools. For example, these are two functions. I can write them in a different way using lambda expression. Okay. So you can define an anonymous lambda expression. So these are the lambda function to calculate the average temperature. And this is how we can do it. Now look, this function calculate the average temperature. Look how many lines it's going to take. Okay, so we will provide the input, perform operation, and finally return the output. So we can do the same thing using lambda function, of course, for some type of situations. So it's defined by the keyword lambda, and then this is the input, and this is the output, the list of operation. So this is called like an inline function that we can define in the same line, especially if the set of operation is controllable. Okay, and we use it in situations like with map, filter, and reduce. Probably now it's the end of the lecture. I'm going to come back on this later. And now we can do the same thing. So, and this is how we're going to call it. So we're going to call it. Look, it looks like a variable, but this actually defines a function. And this function takes one input, temperature. So I'm going to put it here, and then print the result. Okay, so this is the average using the lambda function, and finally we will find 35. We can define anonymous function to filter the hot days. Okay, so same thing here. We use lambda. Hot days takes two inputs. They are separated by a comma, and then double colon here, and then we define, okay, a list. So we return a list using this if statement. This is the comprehension list. Okay, and then to use this function, to filter it hot days. So I'm going to call the function with the two inputs parameters, the temperature and also the threshold. Okay, so this basically introduced most of the concept. There is only few instructions related to map, filter, and reduce. They're already in the notebook, but I'm going to go over them, inshallah, at the starting of the next lecture. Any questions?